Good morning, everyone, and thank you all for coming. And as Dan said, VDC Research is currently the official analyst partner firm for the LoRa Alliance. And what that means is we provide a variety of market research information, forecasts, and white papers and market reports. I've done a couple of webcasts for the Alliance over the last year. Some of you may have seen some of those. Some of what I show here will expand on some of the themes that we've previously introduced. VDC in general works for a wide variety of technology companies everywhere, everything from clients like Intel and Microsoft down to small startups and venture capital firms looking to invest in the IoT and embedded technology markets. So some of the data that we've shown for the Alliance and is based on survey research that VDC has done. And one of the surveys that I showed data from is a survey we conducted in 2022 in February and March of this year with engineers who work on developing IoT products. So in this case, the people we're surveying work for the OEMs or other engineering companies that actually design and develop the products. And this particular survey had 747 engineers, software developers, product and project managers, et cetera. The data that is the percentages in this case represent the portion of manufacturers that use these various technologies. So it's not the percentage of product units, for example. And as you can see from this chart, one of the questions we asked is about use of LPWANs in various IoT products. And we can see here the blue bars were current products, that is stuff they're making this year. The red bars, what they expect to be using 3 years from now in 2025. And we can see that that LoRaWAN technology leads in the responses from this survey, not only currently, but also expected into the future. Somewhat interestingly, I think, is that NB-IoT, which in the blue bars was below LTE-M, actually came out in this survey above LTE-M in the 3 years from now. And I will point out that this was a worldwide survey which included respondents from China, for example, where NB-IoT happens to be particularly popular. US respondents, where we're based, were about 20% of the respondents. Respondents from China were about 10%. And then there are a variety from Western Europe and elsewhere around the world. We can also see Sigfox represented there, still in low single-digit numbers, expected to decline slightly. This was before this survey was taken before the latest acquisition of Sigfox by Unibiz, for example. So that's not factored into anything shown here. We also, as part of our forecasting process, look at the installed base of units, which is more than just the total number ever shipped, because units get taken out of service periodically. They get retired from service. They break down and die periodically. There's also a lag time from when they're built until when they actually get put into service. And here we're showing two variations of the same thing, the worldwide total of active installed units by these technologies in the top chart. And then in the top chart, the red portion of the bars is NB-IoT. And you can see that is quite large. That's primarily because of the impact of China on the market, where NB-IoT has been actively encouraged in a variety of ways by the Chinese government. So the chart on the bottom shows the set totals effectively subtracting out the market for China, and not just for NB-IoT, but the other technologies as well. And we can see in the lower chart, the blue bars on the bottom, the brighter blue bars, are LoRaWAN. And we can see that LoRaWAN is expected to maintain its position as the single largest of those technologies outside of the China market. Outside of China, we also believe that LTE-M will remain the biggest competitor. In the last slide I showed, we said it's possible NB-IoT could take over the second place on a worldwide basis, but that was including China. When we look at the market excluding China, we still see LTE-M being the biggest competitor for LoRaWAN. And Wi-SUN technology, which is primarily used in utilities applications, is still a viable technology. And we still believe that even though it doesn't get a lot of traction outside of the utilities market, it still has some legs in the overall market. And if we look at that installed base by vertical market, that is, and use cases, we can see here the utilities and metering account for the single largest chunk. And this is the entire LPWAN market, not just LoRaWAN. So it includes NB-IoT and LTE-M, et cetera. The reason the utilities and metering market is the biggest chunk is because those tend to be very large deals that include high numbers of units. So a utilities installation for gas or water or other kinds of meters would typically be on the scale of hundreds of thousands of units, in some cases millions of units in a single deal. That's pretty rare in the other use cases to get deals that large. So the utilities chunk is very substantial based on the number of units that are installed, and we anticipate that'll continue to be the case where LoRaWAN specifically and the other LPWANs are really good solutions for the utility metering kinds of applications. Logistic and supply chain applications come in second in the various use cases and verticals here. Generally, that means asset tracking. In most cases, those assets could be cargo shipment, for example, or warehouse and inventory kinds of tracking applications and such. In general, those tend to be somewhat smaller deals than big utilities where there's hundreds of thousands at a time, although the machine queue LoRaWAN service provider did announce late last year a single deal for over 300,000 units in logistics and supply chain use case. So there are some big deals to be had there, although in general it's a lot more aggregation of relatively smaller deals. And as we go down the line, building automation and smart home, that is primarily commercial building automation. You know, when we talk to consumers, the average person, when they think about the Internet of Things, they think of smart home technology, you know, that Nest thermostat and similar kinds of smart home controls. But that particular portion, the smart home portion, is quite small overall in the Internet of Things. Building automation in general is much bigger in commercial real estate kinds of applications and office building management, for example, where the building owners and or operators are trying to keep track of lighting systems and heating systems and room occupancy, where they can, you know, turn off the lights when nobody's there, and track and understand patterns of usage, which meeting rooms get used most frequently, for example, and that will even include in the building automation parking tracking, how many vehicles park in the parking lot of a given building on any given day. Some of the more sophisticated companies doing the analysis of this type of data will even factor in weather data. So they look at external weather information to feed that into the HVAC system, for example, to understand how the weather impacts the need for the heating or air conditioning system usage, or even how the weather can impact the number of people that show up on a given day. If there's particularly bad weather or particularly high temperatures or a hurricane coming or whatever, that will impact how the buildings get used. Industrial automation in the IoT as a whole is actually the single biggest vertical market, but it's been relatively small thus far for LPWAN use cases. That's starting to come online more and more for LPWAN, but big use cases there for wired connectivity, especially Ethernet in the industrial automation market. As well as Wi-Fi and Bluetooth, and there are a number of proprietary wired technologies that are specific to industrial automation. But we are starting to see more LPWAN use cases come up in that. Agricultural and environmental are basically sensors outdoors in the field, whether they're agricultural fields or weather tracking stations, things of that sort. And LPWAN solutions are what we refer to in that particular market as kind of in the Goldilocks zone. I don't know how familiar you folks here are with the term Goldilocks zone from the original fairy tale, Not Too Hot and Not Too Cold. In the scenario for wireless connectivity, it's not too close and not too far. It's not so close that people can necessarily use cellular or local area networking technologies. It's not so far that they have to use satellite-based technologies. It's in that just right Goldilocks zone for low power wide area networks. And that's one in terms of use cases. We do see that growing quite substantially. From a sheer number standpoint, it's still relatively small compared to utilities metering, for example, because you don't typically get hundreds of thousands of devices being installed as part of a single contract. Automotive and transit, that includes both in-vehicle, although that's relatively small for LPWANs today. We will start to see some vehicles, particularly commercial vehicles, trucking, for example, adding LPWAN kinds of functionality, but also transit, including mass transit kinds of applications, trains, planes, and automobiles of all sorts. And that also includes transit infrastructure, so parking lots, toll systems, things of that sort, where we'll increasingly see use of LPWANs. And then last year I'll mention the medical and healthcare. That includes some standalone medical devices, and you may have seen in some of the keynote presentations yesterday some examples of medical devices that would actually be patient wearable devices that can be tracked remotely by the doctors or medical services. But it also includes the healthcare business more broadly. So hospitals, for example, own hundreds of pieces of equipment, and it's just a challenge for them to understand where that equipment is, how it's being used, how often it's being used. Does it need maintenance? And that includes laboratory equipment, things like blood analyzers. They need to understand, is it operating correctly? Does it need new supplies, and so on. So it includes both actual medical data as well as all the other kinds of products and devices that get used in the medical universe. From the survey that I mentioned earlier, just some of the various use cases in that survey. There were about 750 respondents, about 150 of which were using LoRaWAN, and these are some of the assorted use cases. Most of these probably won't come as a surprise to the folks in this room, but the sheer variety of them is really what I want to point out here, even out of a relatively small sample of about 150 respondents in this survey that were using LoRaWAN. The wide variety of these different use cases things like tracking of animals that got reintroduced to the wild. Again, it's depending on exactly where they're reintroducing. LPWANs can be very good in some cases. Satellite tracking would be preferable. Smoke detectors, air quality monitors, and so on down the line. And the last one on the right there, safety monitor for physical therapy machine. That's one that we would not have anticipated, but one of the survey respondents was working on a system for that very purpose. And the airport ground support equipment tracking, this is a great example of kind of that Goldilocks zone where you have a campus environment that may be 1 or 2 square miles of an airport, where LPWANs are a great way to track where those various pieces of what they call ground service equipment, GSE, all those little wheeled things that you see driving around on the airport tarmac, keeping track of where those are is very important for the airport management. So a great use case in particular for LoRaWAN. In our research, we look, among other things, at why LoRaWAN is a great choice compared to both other solutions like cellular, including both conventional cellular, 2G, 3G, 4G, and so on, as well as the cellular LPWANs, such as NB-IoT and LTE Cat-M. Uniquely suitable to both public and private networks. This is really important for LoRaWAN that we try to emphasize at VDC in all our discussions about LoRaWAN, the ease of setting up both a public network, that is, I as an individual, I can buy a gateway, I can buy a Helium network gateway, for example, or any third-party gateway that's on the market, and set it up myself and either use it just for my own purposes or make it openly accessible as a public network to anybody else who wants to use it. I could offer it up free of charge. I could charge people for it. I could join one of the public networks, et cetera, in a hybrid scenario, for example. It's also really easy for end users to connect to LoRaWAN public networks. That is, they don't have to worry about provisioning a SIM card for a specific service provider, for example. It's also extremely easy for organizations to set up a private network to limit access. And this is really important for things like critical infrastructure kinds of projects where they don't necessarily want all their devices to be recognized or tracked as part of a public network. They can set up their own private network to tightly control what devices can connect to that network. It improves security, it improves connectivity for their own specific devices by limiting other devices outside the network. And it's also, I didn't really mention as a specific bullet point here, but if you operate your own private network, you can run application software on your own gateway, right? So you can essentially do some basic types of analytics on the data coming off of the sensors and other devices right on the gateway prior to sending it up to a cloud service or a LoRa network server. You really can't do that in a public network environment. And that's a real driving factor for some of the organizations that are setting up private networks. And the last bullet point there, cellular private networks are only practical, or I really should say economically practical, where voice or high bandwidth applications are in use. It's technically feasible to use them just for LPWANs, but we haven't really encountered use cases where companies are setting up private cellular-based networks just for IoT devices. Generally, it's for broader corporate or enterprise use cases that would include high bandwidth applications and voice applications as well, not just strictly for an IoT network. Also, can connect where cellular isn't. We talked about this Cellular networks tend to be located where people are located. So LPWAN devices may or may not be in the same location. So the concentration of where you want those gateways located isn't necessarily the same as where cell phone towers, for example, would be located. And the cellular industry is very heavily organized around population. You'll see all their stats about what percent of the population is covered. The IoT industry doesn't need to use that same metric at all. They can also be placed in very remote regions using solar power, for example, and even satellite-based services. Some of the newer LoRaWAN satellite services, for example, can certainly go where satellite or where cellular can't. And the last thing I'll mention here about longer battery life. How important this is depends on who you're talking to. So the device manufacturer may not care about this as much as the company that is buying and using and installing these devices for their own use. So from a user organization standpoint, if the batteries die, it means the loss of service. That is, if they're using this for important information to run their business and the batteries die on these various sensors, they don't have that service for that period of time. The service outages can lead to operational problems and faulty behavior in other equipment if they get flaky data, for example. In commercial applications, the labor to replace batteries is generally more expensive than the batteries. And in fact, in a lot of cases, it's more expensive than the entire sensor that they're going into. And depending on how far flung something may be installed, it could cost hundreds of dollars in labor just to send a technician out somewhere to change a battery. Even in relatively modest kind of campus size environments, still sending a technician out there can be, a half an hour or an hour worth of time in addition to the cost of the batteries. Also, in the bottom bullet point there, when the battery dies, the entire device is replaced. That's common for a lot of IoT battery-powered devices now, particularly ones that have relatively long life. It's going to be out there for 5 or 7 years. By the time the battery dies, they may want to just install an entire new device that has new features and functions as part of it. Not that they're in a hurry to do that, but that's an appropriate time often for them to make that type of change. The longer battery life also reduces e-waste. E-waste of the devices themselves that may get replaced at the time the batteries are being replaced, but also the e-waste of batteries, particularly if they use alkaline batteries. Most alkaline batteries are never recycled. Technically, they can be recycled, but it's not economically viable. It actually costs more to recycle the materials in an alkaline battery than it costs to manufacture a new one. So in general, alkaline batteries don't get recycled. So on that note, I'm going to wrap up the session here. We don't really have time for questions because we have another session coming in that's going to start up in a few minutes, but I will be around here at the conference for the rest of the day today. So if you do have questions, feel free to come up to me and ask away, and I'll be happy to try to answer any questions that we have. So once again, thank you all for coming.